6. So I've recorded all my classes today, the questions they have, and I put them in Schoology. I recorded all the ones that were asked Friday. If your question still is not asked, either from watching the videos or, during class right now, then you need to make sure you ask before tomorrow. So like whether you have to email me, come see me later, I don't know, but you need to ask. So 2 different quadratic functions are described below. Function A has a vertex of 4, 1 and passes through the point 2, 5.
They said to power up, girls. Yeah.
Function B, it gives you an equation. There you go, in factored form. And then we need to choose which of the following are true. When comparing them, select all that apply. So we have to check every single one of them. It says only function A is a quadratic function. Well, that doesn't make any sense because it says 2 different quadratic functions are described below. So definitely don't pick the first one. That just makes no sense. Both functions are quadratic functions. Yes, it says so in the instructions. Okay, so don't be that person. I told you there would be at least one person that on their constructed response would say that it's not equivalent when it tells you in the instructions that they are. Yeah, it happens every time. But it tells you in the instructions, these are both quadratic functions. Now function A opens upward, function B opens downward. So for function A, at first, looking at this earlier, I thought, there might not be enough information, but there actually is. My vertex is what part of the U in a quadratic? Well, it could be the bottom or it could be the top. It just depends. So it's the middle of the U. So it's the turning point of the U. So find where 4, 1 would be. So I sketched out coordinate plane. So 1, 2, 3, 4. 1 would be like right here for the vertex. And then it passes through the point to 5. So 1, 2, 3, 4, 5. Hold on, my pen went away from me for a second. Okay, but up 5. Based on knowing that this is my turning point, and then I have another point up here, it must open what direction? Upward or downward? Down. Upward. Upward, because it said that this bottom one, the 4, 1, is the vertex, is the turning point. So then if I have another point that's above it, well then it must open upward. So far this one's looking good. Would you say that function B, which is this equation, would you say that that opens downward? Yes. What makes it open downward? The negative being in front of the x. Because when you FOIL this, you end up with the negative in front of the x squared. That's what makes it open downward. You can also graph it and you can see for yourself, it opens downward. So then take this one. Next one. Function B opens upward, function A opens downward. True or false? True or false? False, because we just picked the one that says the exact opposite. Can't be false. Both vertices are the same. So vertices is plural for vertex. I would have to graph this and see. So never mind, I'm going to take that later. But you do need to graph this and see. So then minus parentheses, was it x plus 1 first? Yes, no. Okay, no, I guess I'll waste time and go back and look at it. X plus 1 is first. And then x plus 3. Like that, graph. Look at its vertex. Is that the same as the other one? What was the vertex of the other one? The other one was 4, 1. It told you. And this one's negative 2, 1. So no, the vertices are not the same. The vertices are different. So we're going to pick the one that says they're different. And then it says the solutions are the same for both functions. Well, what would be the solution for function A based on the little sketch I drew? Where would you normally find your solutions on the graph? On the x-axis? Does this one even touch the x-axis? No, it doesn't. Its vertex is 4, 1, which is above the x-axis. So function A has no solution. Function B has solution because it does have x-intercept. These are the solutions. So it's not the same as function A. So then don't pick the one that says they have the same solution. Pick the one that says they have different solutions. So you should have picked those 4. Questions on that one? Micah? Yes. Questions on others? Kaden? 18? All right. Okay, so this one is a good question. It's like function notation to the max. So first we have that f of x is x squared, which if you guys remember our parent function, that's what that is. If that helps you at all, you can write that on your note card that you're allowed to use tomorrow. Friendly reminder. That's our parent function. We learned any transformation to that results in the graph moving up, down, left, right, maybe getting wider, more narrow. All right, so now we need to basically translate these. So it says that g of x is the same as f of x, except for what's the difference here? So I just need to take what f of x is, which is x squared, and make it negative, which then makes it become negative x squared. How would that graph look? Would it open upward, downward? Downward because of the negative a. So we're between these two. Which one is it going to be? The one that's on the origin or the one that's not? The one that's on the origin. Because the parent function always started on the origin. You could also just graph it and see for yourself. So negative x squared does open downward at the origin. Make sense? Okay. So you just have to basically translate the function notation. So then over here, h of x is what g of x is, which we said that g of x is this, minus 3. So take what g of x equals, plug it in, and then we're minusing 3 from it, which really just becomes this. So you could graph that even, but based on my options that are left, does it open upward or downward? So there's really only one option it could be of those that are left. But if you graph it, you could really see for sure, if you put minus 3 at the end, it moves it down 3. Okay, the x is still 0, but it moved it down, so it didn't move it left or right or anything. And there you go. So questions on that? Questions on others? Zarel? Did you say 2? 3. Okay, so Henry jumps off the diving board into a swimming pool. His height above the water changes according to that function. T is time in seconds, h of t is height in feet. So according to this, what's the maximum height he reaches? So show me like with your finger how he would look in the air. Like what's his travel? Okay, Tyson showed me. Anyone else paying attention? So someone jumping off the diving board, what does that look like? So that's a quadratic function. So if he's on a diving board like this, his path goes up and then down, right? Because the diving board would put him up a little bit. So we're trying to figure out the maximum height, which would be where on this diagram? The very top, otherwise known as our vertex. So we just have to graph this, but remember, probably switch out the t's for x's. So negative 16x squared. Don't forget, friendly reminder, bring your Chromebooks, bring your charger. all the things. Plus 89. All right, no, don't look at any of the negative values, those don't make sense. But you're going to your maximum height, so pretend he's here. Maximum height would be here, but which number, the 0.5 or the 93? The 93, makes more sense, 1. And then 2, that's just saying at 0.5 seconds, he reached 93 feet. So the answer for that one should be 93 for maximum height. I think there was another one that asked like where he started, like how high was the diving board itself. Well, in that case, you look here on the graph, your y-intercept and all that stuff. But yeah, questions on that one? Questions on others? No. Did you say number 7? Okay. So number 7, this one's a good one. Here's what you need to know for this, and then I'll show you with this specific problem. We have 3 different types of functions here. What type of function is the red one? Linear, because it's y equals mx plus b and it's a straight line. What type of function is the blue one? Quadratic, because it's U-shaped and it has an x squared in it. And then what type is this green one? Exponential. These were the main types of functions we learned this year. These are the 3 main ones. Which one tends to grow the fastest out of these 3? Always. Given enough time, like going to positive infinity would be more than enough time. But given enough time, the exponential function will always surpass the other 2. So it might start out like, for example, that the linear one is higher than the exponential function here, but eventually the exponential function always passes it. So when you're answering this, which one will eventually exceed g of x? So which one will eventually exceed the quadratic? It'll definitely be the exponential one. The linear one, it looks like the blue one surpasses it like here-ish. So the linear one would not, just the exponential. So if you just remember that, given enough time, exponential functions surpass the others, then you should be safe. My boyfriend's store. We might have time for one more. Any questions? Adeline? 20. Okay, so what type of function is shown here? A, B to the x? Exponential, maybe put that on a note card or something. What does the A stand for? Initial amount, so your starting amount. And then the B stands for what? Or can you describe the B to me? It will tell you if it's growth or decay. If it's greater than 1, what is it? And then if it's less than 1, it's okay, good. So then this one's asking as f of x decreases, so the y's are decreasing, x is increasing. So the graph is going downward, something like that. So which one would be decay? Which options? These last 2 would be decay. So that narrows me down to 2 options. I think this review put this as the right answer, but really it shouldn't matter what your initial amount is. It really shouldn't. I think because it's negative, maybe they were thinking that. I don't know, but it should be the bottom one. In my opinion, it doesn't matter what your initial value is. It'll still be decay if it's that. So questions, comments, concerns? Okay, tomorrow's the day. Don't forget your note card. Don't forget your charger. Don't forget your Chromebook. A pencil.